Hi folks. So this quick lesson, hoping to do this in maybe under 5 minutes so then you can get some practice, okay, is about symmetry. And we've discussed symmetry when we've been talking about our reflections. What does that mean? That means if I have a coordinate plane and I have a shape or polygon on my coordinate plane, there is a line of reflection that exists all over the place. I'm just going to call it this one, where you have a mirror image of that shape on the other side of the line of reflection. Okay? Well, what we're going to talk about is not just that kind of symmetry this way, but does a shape contain symmetry? And in this picture, it's not a shape, but it's a mask. And we can call this type of symmetry line symmetry. And that connects, of course, with our study on reflectional symmetry. So here we know that this is called line symmetry because if there's a line that exists that I can fold the image where it's going to be the exact same on both the right and the left, I know that this has symmetry. Okay? This is called line symmetry or reflectional symmetry. Right? So what if I was to take this image and twist it? You've seen this on the smartboard before. What if I took this and I twisted it? Do we have the same image? We don't. Okay? So what did I do when I twisted this guy? I rotated this. So this picture has line symmetry or reflectional symmetry, but it doesn't have something that we call rotational symmetry. So I want you to think of what shapes might you know, or what pictures or things might you know that might have rotational symmetry. So pause and I want you to think about a few things and then I'm going to show you a couple of things. So let's talk about these shapes. These are regular polygons. We have to know they're regular. I'm doing that because I'm telling you they're regular. Okay? Let's think about the symmetry this can have. Can we draw a line somewhere on this shape where this shape is going to be the same if we fold it? And the answer, of course, is yes. There's a line that exists here. If I fold that, I can definitely say that it's going to be equal on both sides. Are there more? The answer is yes. I can draw this line, and if I fold it on that line. Are there many more? Yeah, there are many more. Okay? So I want you to think about, with this hexagon, we have line symmetry, or symmetry, or like we said, this is also called reflectional symmetry. So the next question is does it have rotational symmetry? And rotational symmetry is only called rotational symmetry. There's not a second way to call it. That means, is there a center point, and can I twist this guy where it will be the exact same image when I rotate it? And the answer is yes. If I rotate this image 60 degrees, it will be the exact same image. Thus, it has rotational symmetry. So not only does a regular hexagon have line symmetry, it also has rotational symmetry. This is a decagon. Okay? Do you think it also has line symmetry and rotational symmetry? Think about it. Rotational symmetry is, can it be rotated, whereas it's going to be the exact same image? And the answer is yes. How about a square? Yeah, a square too. So this square also has how many lines of symmetry? It has all of these lines of symmetry. And if I was to rotate this around its center, if I rotated it, how many? If I rotated this one 90 degrees, it's going to be the same image. If I rotated this one 60 degrees, it's going to be the same image. If I rotated this one, decagon, pause, think about it if you have to. If I rotated this 36 degrees, right? Decagon, 360 divided by 10. If I rotated this 36 degrees, it's going to be the same image. So not only do these regular, do these regular polygons have line symmetry, they also have reflectional symmetry. Let's look at a couple more. Now I'm wondering if you noticed the difference between this one that I just put out, hexagon, decagon, square, and now I'm going to give you a different one. Okay. So now it's clear that these are also regular polygons. Okay. But the question is do they have line symmetry, which is also reflectional symmetry? And do they have rotational symmetry? So I want you to pause and I want you to think about all of these shapes and see if you can say whether they have line or reflectional. I'm sorry, line or rotational, or both. Now, you've unpaused and you've probably thought it out. Does this have line symmetry? It does, because I can fold it there. The question is does it have rotational symmetry? Can I rotate it on its center where it's going to be the exact same image as what it was when it started? So if I rotate this, can I rotate it so I can get the exact same image? And the answer is yes. If I rotate this 120 degrees, remember our 120 for our triangle? It's going to get the same image. So this has rotational symmetry. Let's look at this one. Does it have line symmetry? Yeah, it has a bunch of line symmetry. But does it have vertex to vertex? Does it have diagonal symmetry? It doesn't, right? These diagonals aren't symmetrical. It's only these lines that are drawn from the vertex to the midpoint. Okay? And that's going to help us guide where that center is. So now here's the other question. Does it have rotational symmetry? And the answer is yes. What is this measurement? 360 divided by 5, I do believe, is 108. Did we get that? 108. Did I do that right? So, with 108 degree rotation, this pentagon will be the same exact thing. So that means it has rotational symmetry. What about this septagon? Will it have rotational symmetry? The answer is yes. Will it also have line symmetry? The answer is yes. Because as I got to get my calculator out, 360 divided by 7 is 51.4. Oh, I did that wrong, guys. Sorry. This is 72. My mistake. This is 108. 72 degrees. Okay? Hopefully you noticed that mistake. All right? This at 51.43 degrees approximately, if I rotate it, it's going to be the exact same image. So all of these have rotational and reflectional symmetry. That means that maybe we can make the distinction that every regular polygon is going to have both of them. Okay? Well, there's another type of symmetry out there, something called point symmetry. And point symmetry is if a shape exists where if you rotate it exactly 180 degrees, it will also be the same image. So let's look at this one. Let's go back to this. If I rotate this hexagon exactly 180 degrees, will it be the same image? And the answer is yes. So this hexagon also has something we call point symmetry. don't worry, I'm going to give you these notes too, but you should be writing this down. Let's think about the decagon. The decagon too, if I rotate the decagon 180 degrees, will I get the exact same decagon? Yes, so this also has point symmetry. What about the square? Yes, the square also has point symmetry. So these regular polygons have line symmetry, which is reflectional, rotational symmetry, and something we call point symmetry, which is pretty much the newest vocabulary word you have. Let's go back to this guy, right? This has line symmetry. It doesn't have rotational symmetry, and it certainly doesn't have point symmetry, because if I rotated this 180 degrees, the top of the head is going to be at the bottom, right? So that means this doesn't have point symmetry. Let's go back to these regular polygons. Do these have point symmetry? If I rotate this 180 degrees, will it be the exact same thing? Hopefully you're saying that the answer is no. Let's look at that. If I rotated this 180 degrees, this point goes over here somewhere. This point goes over here somewhere, and this point goes over here somewhere. So if I rotated this 180 degrees, it would be an upside down triangle, which means that it's not the exact same figure. So that means this doesn't have point symmetry. Either does this one, and either does this one. So we're going to look at a couple more of these, and then I'm going to let you be on your way. I want you to think of this shape. So pause it and decide, does this shape have reflectional symmetry, rotational symmetry, and or point symmetry? Okay, so let's remember, reflectional symmetry is line, rotational symmetry is rotating less than 180 degrees, and point symmetry is rotating exactly 180 degrees. Okay? So you pause, decide on that, and come back to this. So let's look at this guy. Does this guy have line symmetry? Well, I can certainly say that if I draw this line and I fold it, is it going to be the same on both sides? The answer is no. But that doesn't mean it doesn't have line symmetry, okay? Because I have to look for some other lines. Just like if we go back to the mask, right? If I was to draw this line, it doesn't have line symmetry there. But it does have line symmetry because there is a line that exists that creates symmetry. So let's look for another line that might exist. Does this line exist? The answer is no. What about diagonal lines? What if I was to cut it like this? Now remember, when you're looking for reflectional symmetry, you're saying, can I fold it where it's going to be exactly the same on both ends? So the answer is no. There is no reflectional symmetry here. All right? Now, this question is, so I kept this going so you could see. I rotated this 90 degrees from here to here. Is it the same image? The answer is no. If I kept rotating it a little bit more, of course the image isn't going to stay the same. All right? Now, if I keep going, look down here, and I rotate it 180 degrees, it is the same image. So here's my 180 degrees, and here's my 90 degrees. So because it has a 180 degree rotation that keeps it the same, it's called having point symmetry. Okay? And because at 90 degrees it's not the same, it does not have rotational symmetry. Now, are there some shapes that have all three? Absolutely. Are there some shapes that have rotational and point? Absolutely. But there are also some shapes that have point symmetry that don't have rotational symmetry, because rotational symmetry is when a figure that its own image of less than 180 degree rotation will be the same. Okay? So if it's rotational symmetry, the image has to be rotated less than 180 degrees. And if that image is the same as the figure that has its own image, okay, that is its own image, if that figure is its own image on a rotation of less than 180 degrees, it's something that's called having rotational symmetry. Point symmetry is a little bit more specific, however. It's rotational symmetry, but it's exactly 180 degrees. So it's a very special type of symmetry. It's a figure that its own image with that is its own image with exactly 180 degrees. So like we said, this equilateral triangle has rotational symmetry. But it doesn't have point. Okay? The shape that I just showed you, where's that shape? Here it is. The shape that I just showed you, this one, has point symmetry, but not rotational. And then, of course, those regular shapes, I want you to decide what's so special about these regular shapes. We'll talk about them in class. These regular shapes have all three. Your job is to try to figure that out for all of the shapes that you're going to see in your notebook, in your textbook. I'm going to give you about 10 minutes of written homework that I want you to do around symmetry. We have, again, reflectional, which is also line symmetry, rotational, which is that less than 180 degrees rotation, and point symmetry, which is an exactly 180 degree rotation. Okay, so I want you to think about this. If you need to watch this video again, you can. If you need to pause and take notes, you can. And then I want you to spend about 10 minutes doing a couple of questions from the textbook.